Hello everyone, and welcome back to my YouTube channel or the VIG Structure Hub. This is a place where you learn, build, and innovate. Today I want to tackle example number 1, and this is a question from Kenya National Examination Council, Module 2. The question is on the board and it reads, a mass concrete dam shown below has a trapezoidal cross-section. The height above the foundation is 62 meters and its water face is vertical. The width of the top is 4.5 meters and the base is 36.35 meters. Determine the maximum and minimum stress at the base. The question carries 20 marks and you have been told take the unit weight of concrete as 23 kilonewton per meter cubic and the unit weight of water is 9.81 kilonewton per meter cubic. So if you are a KNEC student pursuing module 2, this question is for you. Again, if you are a CDAC student, this question is for you. So stay tuned up to the end of the question. So the first thing to do is to split this trapezoidal dam into rectangular shape and triangle shape. So you will split like this. So this is a rectangle and this is a triangle. Then solution. So the first thing again is to determine where our force is acting from. So the force is on the water body. So this force we are shown is acting at this point. So that is our force. And then you extend again. So that is our force F. We have another force as a result of the weight of the dam. So this one is at this point. So this is our W and this is our center of gravity, COG. And then this force F and W produces a resultant force, which is R. So R, it is in between W and F. And it cuts the base of the dam at M. So here is M. And this is R, which is the resultant force. Again, remember, where this force W is acting is the center of that dam. So we call it N. And then this point is A. And then this is M. So after doing so, we can clearly see where our X is, our distance X. So our distance X is at this point. So that is distance X. And then we have our distance D. Distance D is AN plus NM. So this is our distance D. And then we have our distance B. So that is B. And then this is our distance A. Again, we have the height of the dam. So the height of the dam is 60 plus 2. So that is 62 meters. So having done so, we can now begin solving this question. Again, we have this distance. The center of the pressure is H over 3. Like that. So solution. The first thing to do is to calculate this force of the water acting on one side of the dam. And the force, in our previous analysis, the formula for calculating force is W, small w, times H square over 2. So this one is equal to, small w is the unit weight of water, which is 9.81 times H. H is the height of water, which is 60 times 60 square over 2. Then you punch your calculator. Our H is 17.658 times 10 raised to power 3 kilonewton. That is our F. After calculating F, then you are supposed to get the value of H over 3. So H over 3 is equal to 60 over 3, which is equal to 20 meters. So our F is equal to 17.658 times 10 raised to power 3 kilonewton, acting at 20 meters from the base. From the base of the dam. So we have already calculated our F and find where it is acting from the base of the dam. After doing so, we'll proceed to W. So this is capital W. So W is equal to the weight of concrete, unit weight of concrete, times area times length of the dam. So in this case, allow me to rub here. So the unit weight of concrete, so W is equal to unit weight of concrete. We have been told to use 23 kilonewton per meter cubic. So the unit weight of concrete is W0 times area. So that is a half A plus B times H, then times the length of the dam, which is 1. We consider 1 meter length of the dam. So the area, it will be the area of the trapezium. So this one will be 23 times a half into bracket the sum of two parallel sides, that is 4.5 plus 36.35 times the height. Height is the height of this dam, which is 62, then times 1. Again, you punch your calculator. So the answer is 29.12605 times 10 raised to power 3 kilonewton. So that is our W. After calculating our W, we'll proceed to distance X. So distance X is this distance here from N to M. So that distance is given or is calculated using this formula, F over W times H over 3. So our F is 17.658 times 10 raised to power 3 over 29.12605 times 10 raised to power 3, then times H, small h, which is 60 over 3. Then you punch your calculator to obtain your answer. So the answer is 12.1252 meters. After calculating distance X, we'll proceed and calculate distance AN. So distance AN. So this one, you can use this expression, which is A square plus AB plus B square over 3A plus B. So this one is equal to, so distance AN is equal to, A is this distance from here to here, that is 4.5 square plus 4.5 times B is from here to here, which is 36.35 plus 36.35 square all over 3 into bracket 4.5 plus 36.35. Punch your calculator to obtain distance AN. So AN is equal to the answer is 12.28 19 meters. So that is our AN. You can also calculate this value AN by considering this method. So you find first the area of this rectangle times its centroid plus the area of this triangle plus its centroid. Then you equate to the area of this trapezium times AN. Then you make AN the subject of the formula. So let me show you how you can do it. So the area of the rectangle is length times width. So it means 4.5 times the height is 62 times the centroid coming from this side as you proceed to the other side. So it will be 4.5 over 2 plus the area of the triangle is a half base times height. So it will be a half times the base is 36. The base is 36. 36.35 minus 4.5. So 36.35 minus 4.5. That is 31. 31.85 times height is 62. 62 times the centroid. Because we are coming from this side, we take this distance 4.5 plus h over 3, which is 31.85 over 3. Then is equal to the area of the whole trapezium is a half into bracket a plus b 4.5 plus 36.35 times 62 times AN, like that. For more calculation, so if you can punch our calculator, so 4.5 times 62 times 4.5 over 2, we will have 27.75 plus this one. So 4.5 plus 31.85 over 3, then times 62 times 31.85 times 0.5. So plus 14, 9, 25.44083 is equal to 4.5 plus 36.35 times 62 times 0.5. So it's equal to 1266.35 AN. So which imply AN is equal to 627.75 627.75 plus 14, 925.44083. So that is 15, 5, 3.919083. Then you divide everything by 12, 66.35. So AN, therefore, AN is equal to 12.2819 meters. So it's the same as proceed to distance D. Distance D, this distance is equal to AN plus NM. So AN is equal to 12.2819 plus NM. NM is distance X, which is 12.1252. All of these are in meters. So 12.2819 plus 12.1252. So the answer is 24.4071 meter. So this is the distance D. After that, we now proceed to E, which is eccentricity. So eccentricity is equal to D minus B over 2. So our D is 24.4071 minus B over 2. B is this distance from here to here, which is 36.35 over 2. So let's punch our calculator to obtain E. So our E is 6.2321 meters. After we have done with our E, we'll proceed to stresses across the base of the dam. So stresses across the base of the dam. So we begin with stress at B, which is the maximum. So the formula will be W over B plus 6 times W times E over B square. But W is equal to the weight of the dam. So which is equal to weight of concrete, which is 23, times the area of the dam, that is a half, A plus B, 4.5, plus 36.35, times H, which is 62. Then times the length of the dam, which is 1 meter length. So then punch your calculator to obtain the answer. So that is 29.12605 times 10 raised power 3 kilonewton. So our our stresses mass is equal to 29.12605 times 10 raised power 3 over B. B is this distance from here to here, which is 36.35 plus 6 times 29.1260 times 10 raised power 3 times E, which is 6.23, then over B square, that's 6.35 square. Punch your calculator. The answer is 1.6252 times 10 raised power 3 kilonewton per millimeter square. Or you can make your answer, or you can convert your answer into Newton per millimeter square by multiplying 10 raised power 3. So the answer will be 1.6252 times 10 raised power 6 Newton per millimeter square. Then we proceed to minimum will be stress at point A. So which is equal to W over B minus 6 times W times E over B square. So this one will be 29.12605 times 10 raised power 3 over 36.35 plus 6 times 29.126 times 10 raised power 3 times 6.23 over 36.35 square. Again, you carry out the operation. So this is minus, not plus. This is minus. So the answer is 22.7 kilonewton per millimeter square. So which will be times 10 raised power 3, 22.702 Newton per millimeter square. So that is the answer, and that marks the end of that question.